Go, ready. Oh, it's going. Okay. So this is 7-3 part 2. Okay. B. And this is called partial fraction decomposition. It sounds really complicated. It's a little complicated, but it's not that bad. Okay. So if you have a fraction that looks like this, x plus 7 over x squared minus x minus 6. I think the best way might be to take you through how you do one, and then I'll kind of write down what the steps are. Okay? So, yes?
Wait, you factor the bottom part and then put the 3.
Yeah, you've done this before?
Yeah.
So what you want, what partial fraction decomposition is, you write this as the sum of two fractions which only have, this is a quadratic on the bottom. What you want to do is you want to have linear factors on the bottom. So this bottom part, what you do is you factor the bottom part. So who can tell me how this bottom part factors? You got to be kind of good at factoring. X minus 3 and x plus 2. So what you do is you rewrite this as, well, I don't need a parentheses here. You rewrite this as x minus 3 on the bottom and x plus 2 on the bottom of this one, and an a up here and a b over here. And why would you ever want to do this? Yes, sir?
Why is it a and b not x plus 7?
Because it's not, for the same reason that 3, like, you can't just add these together because it's not, because this is not equal to x, it's not equal to x over x minus 3, right? Plus 7 over x plus 2. It's equal to a, some number, it's equal to x over x squared minus x minus 6.
Okay.
And 7, so it's not just over x. And the reason that you want to do this is because it's a calculus thing. When you get to calculus, which many of you will next year, they'll ask you to do this. They'll ask you to take the integral of the left side. And this integral is impossible to take the integral of, whereas things that have constants on the top and algebra stuff on the bottom, those are easy to take the integral of, okay? So, and if you're taking AB, you don't really have to know how to do this, but if you're taking BC, I heard Mrs. Hine teaching it the other day. So she'll teach you this again, but it's here because you have to do this in calculus because it's this algebraic step that you need to do to get to the calculus. So you want to figure out what two numbers go here and here, such that if I multiply them together, I get an equivalent expression to that, okay? So the way you do it, you factor the bottom, and then you multiply both sides by that bottom, okay? So I'm going to multiply both sides by x minus 3 times x plus 2, and I'm going to, time to go. I'm going to multiply this by x minus 3, whoops, that should be on the top, times x plus 2, okay? And the reason I do that, what happens to x minus 3 times x plus 2 when I multiply the left side by it? This whole thing is the same as this, so that goes away. So on the left side, I'm left with just x plus 7. And on the right side, I'm left with, well, this cancels with this, and I'm left with a times x plus 2. And this x plus 2 cancels with this x plus 2, and I'm left with b times x minus 3. Do you guys understand what I just did there?
Yeah.
Anyone doesn't get that? Okay, so what I did is I multiplied both sides by the factored form of the denominator, and the x minus 3 cancels here. And so on the top, you just have this. And then to solve for a and b, one way to solve, yes, sir?
So what do A and B stand for?
They're numbers that I'm going to figure out what those numbers are in a second, okay? And I'll show you how you rewrite this in a minute, okay? So I'm going to, one way to solve this is to let x equal something that's going to make one of these terms disappear. So what could I let x equal to make this term disappear? Negative 2, right? And if x is negative 2, I plug in negative 2 everywhere I see an x. So I get negative 2 plus 7 equals, well, if I plug in negative 2 in here, it just disappears, right? So I get equals b times negative 2 minus 3. So I get 5 equals negative 5b. So b equals negative 1. And now I have to find a. Okay? So to find a, what should I let x be? Very good. Let x equal 3. Do you guys see why I want x to be 3? Because I want this term to disappear. If I let x equal 3, then I get 3 plus 7 equals a times 3 plus 2, right? Which gives me 10 equals 5a, which gives me a equals 2, okay? Which means that I can rewrite my original expression, okay, as x plus 7 over x squared minus x minus 6 is equal to 2, which is a, over x minus 3 minus, since this is minus 1, I'm just going to, instead of putting minus 1 on top here, I'm just going to come minus 1 over x plus 2. So if I found a common denominator and multiplied these together, this is what I would get after I simplify. Do you need that to go up higher, Ben? Yes?
Yeah.
Why do you do that?
Why? Because this is really hard to do, okay? The integral of 2 over x minus 3, I happen to know, is natural log of x minus 3. That's the integral of this. No, it's not. It's 2 times the natural log of x minus 3. So if, because algebraically, this is easy to do, okay, but algebraically, this is like you have to use all kinds of substitution and stuff. So that the only reason you change it over is because for calculus. That's why you're doing it. That's why you learn it here is pre-calculus, right? You're doing the algebra to prepare yourself for calculus. Okay? So
Wait,
that
can't you switch those? Shouldn't 2 be over the x plus 2?
no. No, A, so A was A, we solved for A and we got A is
Oh, I switched.
A goes over there. Okay?
Yeah, I see.
So you want to do another one? No? Okay, you want to just show
Give us
now?
the steps.
The steps. Yeah, so so the steps are steps, sure. Steps for steps. Steps for decomposing partial fractions, okay? Zombies are really good at this. Because they're always decomposing, you know. Zombies. Beethoven was pretty good at this too, because he composed a lot of symphonies in D, so he was decomposing all the time. Okay. You don't get that one? He was composing. So now what if we had something like this? Oh, steps. 1, factor the denominator. Factor the denominator. Denominator.
It's always the denominator.
Yep. And 2 is rewrite as A over factor, I don't know how you say it, A over linear factor plus B over factor plus c over factor, something like that, okay? And plus dot, dot, dot. However many factors, you have to write it as a plus c plus a plus b plus c over, and these are actually called linear factors. Linear factors. And then 3 multiply both sides. Multiply both sides by the factored form. The factored form of the denominator for, we're going to simplify and solve for constants for a, b, c, etc. And then finally, don't forget to rewrite the right side with the a, with the b, and with the c. But this part, so some of these things could run you into trouble, like multiply both sides by, that's easy. But sometimes solving can be kind of a problem, which I'm going to do. I'm going to show you another way to solve one of these. Okay? You ready? You ready? I don't have any more jokes. I'm sorry. So,
Should I do a dirty joke?
no, I don't have it. All I have is a clean joke. Okay, no, I can't do that right now. I'm busy. All right, where's my new page? Okay, so what does this do? I don't want to. I want to hide that. Okay, so repeat it. So here's a decomposition with not with repeated, with multiple linear factors. So if you see if they say something like decompose, and I'm very good at 2x squared minus 3x minus 1 over x cubed minus x. Okay? How do I factor that bottom? What could come out of the bottom? X times x squared minus 1, but x squared minus 1 could factor as well. Anyone? It's not just x plus x minus 1 times x minus 1.
It's like x minus 1 plus 1.
It's x minus 1 times x plus 1. Okay? So this is equal to 2x squared minus 3x minus 1 over this. Okay? And then you rewrite that. Okay? So you're going to rewrite 2x squared minus 3x minus 1 over x times x minus 1 times x plus 1 as a over x plus b over what? X minus 1 or x plus 1, but it doesn't matter which one comes first or which, times c over x plus 1. So you write each piece over one of the linear factors. Then you got to get rid of those, okay? So you're going to multiply both sides by x times x minus 1 times x plus 1. And when I do that, this goes away. And over here, I get that 2x squared minus 3x minus 1 equals a times what? X minus 1 times x plus 1. I'm just going to keep going. Plus b times x times x plus 1. Plus c times x minus 1. Does anyone have any questions about what I just did? So what I did is this x cancels with that x, right? And then I have on the top x minus 1x plus 1. Yes? We're good?
Yes, sir.
Good. Okay, now I'm going to show you another way to solve this that you might not like. But, so what you could do, in this case, you can't always do this. So I could let x equal 1, and this term will disappear, and this term will disappear. Then what else could I let x be? Negative 1, and this term will be disappear, and this term will disappear. And then let x equal what? 0, and then this term will disappear, and this term will disappear, and I'll be able to solve for a, right? That's probably the easiest way to do that. But in the book, they teach you something called equating coefficients. And it's another way to do it, and some people like it better, but some people hate it. But I'm just going to take you through it to show you what it looks like. Okay, oh, we're going to do it in green, too. Okay, uh-oh, I'm getting important text messages right now. So 2x squared minus 3x minus 1. So this is called the equating coefficients method. So what I'm going to do is I'm going to multiply these two things together. And I'm going to get a times x squared minus x. If I FOIL this out, no, is that what I get? X squared minus 1, sorry. If I FOIL this out, this x plus 1 times x minus 1, I get this. Plus b times x squared plus x. Do you guys see what I'm doing? Plus c times x squared minus x. Then what you do when you're equating coefficients, so what I'm going to try to do is I'm going to take all my x squared terms. I'll keep going, okay? So this is equal to, now I'm going to distribute ax squared minus a plus bx squared plus bx plus cx squared minus cx, okay? And then I'm going to group all my x squared terms together. So, and all my x terms together. Whoops. How did I get 2 bx's? Oh, one should be x squared, okay? So I'm going to group all my x squareds together. So I have ax squared plus bx squared plus cx squared. And then I'm going to group all my x terms together plus bx minus cx. And I'm going to group my one constant term, which is this one, together. Okay? And then what I'm going to do, now I'm just trying to show you this so that you can see where this is coming from. A plus b plus c times x squared. I'm factoring out my coefficients. B minus c times x minus a minus a. So 2x squared minus 3x minus 1. What that means is that a plus b plus c must be equal to what? 2. See that over there? Because there's x squared over there. So I know that. So what I do is I write a system of equations. A plus b plus c equals 2. I know that b minus c has to equal to what? Negative 3. Do you guys see where I'm getting this? That's the coefficients of these terms on the left side. And I know that negative a is equal to negative 1. Do you follow what I just did?
Yeah.
Okay? So, again, you could have done this by letting x equal 1, x equal negative 1, x equal 0, but sometimes that doesn't always work. So you need to have this too. So this means if I solve this system, if negative a is negative 1, then a equals what? 1. Okay? If I take a equals 1 and I plug it in over here, right, I get that, I'm going to change colors, I get that b plus c, take away 1 from both sides, equals 1. And I get that b minus c equals negative 3. And then I add together those two equations, that goes away. I get 2b equals negative 2, b equals negative 1. And then I could solve that, and I get that c is, what's c? C is 2. If b plus c is negative
2.
B is 2, right? C is 2, okay? And C equals 2. So when I solve that system, that's what I get. A is 1, B is -1, C is 2. So going way, way back to my original equation, which if I were writing on the board would still be there, okay? I could rewrite this thing, or I'm going to take a picture of it. No, I'm not. I'm just going to rewrite it as this is equal to, what was A? Someone keeps texting. A is 1, so I could rewrite this as equals 1 over x. B was what? B was -1 minus 1 over x minus 1 plus 2 over x plus 1. Okay? And if you're doing calculus, all of those things are really easy to integrate, whereas this thing would be like impossible to integrate. Integrate is how you find answers to calculus problems and derivatives. Okay? I'm not quite done yet. We need to take a brain break. That's what my book says.
I think we need some.
Last one. Okay, last thing. I don't know if I'll take you completely through this. Are we recording now? We're recording. So I'm going to new piece of paper. So this is called repeated linear factors. If you see repeated linear factors, like I'll show you. Okay. If you see something that looks like this, which you might, 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x. If you factor the bottom, on the bottom you can take out an x. You get x times x squared plus 2x plus 1. But that bottom factors again. Who can tell me what x squared plus 2x plus 1 factors to? X times x plus 1 squared. Like that. So it's 5x squared plus 20x plus 6. So this is called the repeated linear factor because it's the same factor twice. When you're trying to decompose this thing, 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x, this is equal to a over x plus b over x plus 1 plus c over x plus 1 quantity squared. Okay? So you have to write it over each one of the factors. So this factor will go into here, this factor will go into here, but also x plus 1 squared will go into there. So that's the way you have to write it. Don't ask me why, it just works out that way. Okay? Then if I were going to, let's just do the A, B, and C method really quick. Okay? So if I get, no, let's not. Can you finish this? Could you guys finish this?
Yeah.
I'm going to multiply. Let me just simplify it a little bit. So I'm going to multiply everything by the factored form of the bottom, x plus 1, like that, right? And then I get that this is equal, so I would get, if I multiplied that out, that 5x squared plus 20x plus 6 is equal to a times what? A times x plus 1 squared, right? Because the x's would cancel out with that, and I'd just be left with x plus 1 squared, plus b times x times x plus 1, plus c times x, right? And then probably what I'm going to do, I'm not going to finish it. I would let x equal -1, would make these two terms cancel out. What else could I let x be? 0. Let x equal 0. And then what's going to happen here? So if you let x equal -1, you'll be able, well, let's just do it, okay? If x, can I do it? Just do it?
Yeah.
Okay? Yeah, let's just do it. So if x equals -1, I plug -1 in here. Don't forget that you square this first and then multiply that. So when x is -1, I get 5 minus 20 plus 6 equals, this disappears, and I get -c. Yeah? So I get 5 minus 20 is -15 plus 6 makes -9 equals -c. So c equals 9. Okay? Then I'm going to let x equals 0. So when x is 0, that's easy. I get 6 equals, right? Because if I plug in 0 in here, I get 6. And over here, this term disappears, and I get 6 equals a times 1 plus 1, whoops, not 1 plus 1, 0 plus 1. And c, so I just get, if I plug in, right, if I could plug in x equals 0, I get a equals 6. But then the problem is that now there's nothing else that I could let x be that's going to make things disappear, because I already let it equal to -1 and 0. So what I do is I let x equal anything I want. Let x equal 1, but I sub in my a is 6 and my c is 9. Okay? So if x equals 1, I get 5 plus 20 plus 6 equals, I know a from this problem, right? So I'm going to take my a and I'm going to plug it in here, right? So I get 6 times 1 plus 1 squared, and I know that's 4, but and then I get plus b times 1 times 2 plus c, which is 9, plus 9. You follow what I just did?
Yeah.
And then you could find out what, did I do that right? I think I did that right? So I get, what's that, 25 plus 6, 31 equals 24 plus 2b plus 9, 2b equals -2, b equals -1. And then I just plug those numbers in up here, right? So I have a, I plug in 6 up here, I plug in -1 up here, and I plug in 9 up here. And then I'm done. Okay? So that's what partial fraction decomposition looks like. There's other parts to it, like sometimes, just to show you, I think number 67 is in your homework, but if you don't want to do number 67, you don't have to, okay? But in number 67, you have a cubic up top, something like this, 2x minus 1 up top, and you have a squared problem on the bottom, something like this. And what you have to do is use long division and divide that into that. Don't worry about it, okay? And then sometimes you end up with things that don't factor in the bottom, like x squared plus 2x, or x squared plus 2, which wouldn't factor. And so if you had something like this, if you had this is called a quadratic factor, you have to rewrite the top as this, ax plus b plus c over x plus 1. But I didn't assign one like that in the homework. Anyway, that's all. I'm done. Okay? So, I talked for how long? Too long.